Oh, hey there. Welcome to our Unit 6 review, which focuses on functions. It's going to be really fun. If you just rolled your eyes, then it was mission accomplished. So first of all, what is a function? What is a relation? Well, a relation is a set of ordered pairs. A function is a relation with no repeated x values. So what I have are a bunch of different ways that we can have relations and functions displayed. The first is an arrow diagram, second is a list of ordered pairs, and the third is a graph. So with arrow diagrams, notice how on the left you have your x values and on the right you have your y values. Each x has a y value and no x is repeated. So like this is the coordinate 1b. This is 2a. This is 3b. It's okay that the y value is repeated, but because no x values are repeated, this is a function. But over here, I'm already seeing a repeated y value, or excuse me, repeated x value for my input or my x values, which means this is not a function. Okay? Ordered pairs, again, I just look through my x's. I'm like, okay, did anything repeat? No, it didn't. So therefore, this is a function. Okay, look through again. 1, 2, 1, 5. Oh man, I said 1 twice. Look how fun that is. I just put blue over the yellow and it made a green. Wow, that's exactly how I would expect that to work. Anyway, so this is an art class. My ones repeat, or my x's repeat, so this is not a function. Graphs are my favorite way to check whether something's a function or not, and we do this by doing the vertical line test. So what this says is I draw a vertical line. If it intersects twice, then it's not a function. Not a function. Third one's cool though. Only intersects once. So this one is a function. Now this one, I gotta zoom in here because this is a super tiny graph. Okay. Ooh, good, that focused nicely. What you may or may not see on your packet is that this dot right there is closed while that one is open. So if you are to do the vertical line test, it would pass because the only place it's intersecting is at the closed dot. Likewise over here. Top one's closed, this one's open, it's only intersecting there, so this will be a function. That's just like the tiniest graph in the world though, so hopefully you could see that. Okay. Function notation. F of x is just a fancy way of really saying y, where this x right here represents an input value. This is the expression that will represent your output. So for example, if I want to know what h of negative 3 is, I just plug in negative 3 for x and evaluate. Okay, so my answer would be 2. On the graph, this is my x value, so I go to x equals 1. I see where it comes out on the graph. Looks like we're coming out at a negative 3, so that would be my answer. Go to negative 2 for the next one. Looks like my output is a y equals 1. Now this is phrased differently. Find x when f of x equals negative 5. So aka, when y equals negative 5, what is x? So this is where I would draw the horizontal line y equals negative 5. So 1, 2, 3, 4, 5. I notice it's intersecting there, and then I say to myself, okay, what's that x value? it was at -1, and that's your answer. So that's like the opposite of what I was just doing with the other two. All right, something else we talked about this unit was average rate of change, which is just calculated using your slope formula. Hopefully by now you have that guy memorized. That's just your change in y over change in x. So typically what we'll have you do on the exam is find the average rate of change on a function and compare it to another function on the same interval, and you have to say who has the greater average rate of change or the smaller average rate of change, something to that effect. So if I want to calculate the average rate of change on this function on the interval of 1 to 3, there's a couple things you could do. First is algebraically even figure out what the coordinates are. Keep in mind this interval are x values. So if I find f of 1, that would be 1 squared plus 1, which is 2. So my first coordinate is 1, 2. F of 3 would be the same thing as 3 squared plus 3, which is 9 plus 3, which is 12. And then you do the slope with those points. Now something else you could do is use your calculator to help you to get those values. So depending on how complicated the expression or the functions are, sometimes I'll just jump right to doing this. So if I plug the function in for y1, so x squared plus x, and then I go to my table, the coordinates I need. So I can pick out the coordinates that I need from here. So 1, 2, and I wanted when x equals 3, and that's where 12 comes from. So either way, x, y, your coordinates are 1, 2, and 3, 12. So you either get them algebraically like this, or you can pull them from your calculator, put them in a table. You're going to do the slope with those. So change in y, so 12 minus 2, over change in x, 3 minus 1. Notice how I went from 12 to 2, which means I have to go in the same order. So 3 minus 1. If you accidentally flip it, you'll be off by a negative. That would be 10 divided by 2, which is 5. And that's your average rate of change. All right, operations on functions are exactly what they look like. F plus h of x is addition. Addition of your functions. That's subtraction. This is multiplication. That's division. So in these problems, I'll give you 2 or 3 different functions, and then I just want you to do operations on them. I could have you do them for all values of x or a specific value of x. So for instance, this guy, I want g minus h on the x value of -1. So what you should do is figure out what g of -1 is and h of -1 is, and then subtract them. So if I go to my g function, this is 3 times -1 minus 2, which would be -3 minus 2, which is -5. H function would be -1 squared minus 1, which is 1 minus 1, which is 0. -5 minus 0 is just -5. And then you're done. Now here, you'll notice that I don't have a value in for x. I just say find h times f of x. So that's representing a function for all values of x. So my h function is x squared minus 1. My f function is 5x plus 1. And then I just multiply those. And that's as combined as it's going to get. So that's my answer in standard form. Okay, this just wants me to add my functions for all values of x. So my h function is x squared minus 1. My g function is 3x minus 2. So that would be x squared plus 3x minus 3. And then lastly, this wants me to find what g of 2 is, find what f of 2 is, and then divide them. So my g function would be 3 times 2 minus 2, which is 6 minus 2, which is 4. My f function would be 5 times 2 plus 1, which would be 11. So this would be 4 11ths. All right, let's find the inverse of some functions. In order to find the inverse of really any function, you're just switching your x and y values. So graphically, that would be like taking your function that looks like this and switching all the x and y values, and then he'd look like that. Ultimately, it's just a reflection over the line y equals x from a graphic standpoint. From an algebraic standpoint, what we'll do is take any f of x and rewrite him as y. We will switch x and y and solve for y. So if I want to find the inverse of y equals 2x minus 5, I'm going to switch x and y. And now you have to solve for that y right there that I highlighted. So you would add the 5 over, so that would be x plus 5 equals 2y, and then divide by 2. So you could leave it like that, or if this is a multiple choice, you may even see it as 1/2 x plus 5 halves. So be prepared for either scenario. And then additionally, we're going to tack on our inverse symbol. So y inverse equals 1/2 x plus 5 halves, or f inverse of x equals 1/2 x plus 5 halves, especially because in this problem it says find f inverse of x, so I made sure I labeled it as such. Okay, but again, if you wanted to leave this as x plus 5 over 2, that would be mathematically equivalent, but you may see it in y equals mx plus b form in a multiple choice, so just be prepared. All right, try the next guy. Switch x and y. So this is y. I'm going to rewrite it as x. Okay, now we need to solve for y. First thing I would do is divide by 3. So we have x over 3 equals y squared. In order to solve for y, then I'd have to take the square root. So y equals the square root of x over 3. Do not bother putting a plus or minus there. You're not solving. And in fact, if you do put a plus or minus, then it would no longer be a function. So just be careful there. Sometimes they'll throw that in a multiple choice to try to trick you. So your inverse is just radical x over 3. Okay, last one. I'm switching x and y. Okay, now I'm going to cube both sides. Undo that cube, because I got to solve for y, so I got to undo the cube root. So I have x cubed equals y minus 4. Add the 4 over. I don't know if my laptop is picking this up, but my dog is snoring like really loud not too far from me. So if you hear snoring, it's my dog. All right, I've isolated y, so now I'm just going to rewrite this as f inverse of x. All right, now our next section is on composition of functions. So that is with this symbol right here. Notice how it's open as opposed to closed. Closed would imply multiplication. It could be in something called nested notation as well. What's important to note is that those are read backwards. So this is f of g of x. Okay, so if I want to find f of g of 6 given these functions f and g, again, think about it backwards. The first thing you're going to do is figure out what g of 6 is. So I go to my g function, that's x squared. So that'd be 36. So now what it wants me to do is take this 36 and plug them into the f function. I evaluated it in my f function, and I got 38. All right, this says find f of 3 and then plug that into your g function. So f of 3 would be the same thing as 3 plus 2, which is 5. So then if I do g of 5, that would be 5 squared, which is 25. Now lastly here, this is evaluating for all values of x, not just a specific one like 6 or 3. So what this is ultimately saying is you want to take your g function and plug him into the f function. So first of all, think about what your f function is. Your f function is x plus 2. I want to now take that f function and replace him with the g function. So notice this little substitution I did. I know the g function is x squared, so f of g of x would then be x squared plus 2, because I knew that they were equivalent. That's kind of a dark pink. Let me do this in a light blue. And then you're done. All right, something else we talked about with functions, domain and range. Domain is your collection of your x values. The range is your collection of your y values. So for our first graph right here, let me zoom in because this is kind of small for me to do on my computer. Looks like we're going between -3 and 1, 2, 3, 4, 5. So I would say my domain is between -3 and 5. Notice my notation there though. I did a hard bracket at 5 because it was closed, open at -3 because it was open. Soft bracket, I should say. Now my range is only a single value. Every single one of those points on that horizontal line just has a y value of -1. So my range is just a single value of -1. Okay, coming over to my next graph, looks like this coordinate is 1, 2, 3, 4, -4, 1, 2, 3, 4. And then this coordinate looks like it's 2, -2. So my x's are between -4 and 2. And because each of those dots are closed, I'm going to do hard brackets. And my range is between 4 and -2, because that's my change in my y's. And again, hard brackets because it's closed. All right, domain, my x's, so looking from left to right. Okay, this coordinate looks like it's 1, 2, 3. So -3, 1, 2, 3, 4, 5. This one over here is 1, 2, 3, 4. And then 1, 2, 3, 4, 5 again. All right, and then this coordinate down here is 0, 0 at the origin. So that could be helpful as well. All right, so again, domain. As I look from left to right for my domain, my x's are between -3 and 4. Since it's open at those points, I'm going to do soft brackets. Now my range is where I go from bottom to top. My lowest y value is occurring at 0, and my highest y value, either here or here, is at 5. So it's between 0 and 5. Now it's closed at 0, so we're going to do a hard bracket, and then it's open at either one of these, so we're going to do a soft bracket at 5. And that's our domain and range from our graphs. All right, next we got some piecewise functions, which are literally just pieces of functions put together on a graph. I need to use this grid to figure out how to evaluate. First of all, let me find the origin because I'm not entirely positive where it is right now. I think this looks darker, and this looks darker. Okay. I'm pretty sure that's my origin. Ooh. Okay. So if I want to find g of negative 2, and this is my g function, this is my x value. If this is the origin, I'm going to go to negative 2, so 1, 2, and then go up 1, 2, so it looks like my output is at 2. So that would be my answer. Okay, g of 4. 1, 2, 3, 4. So based on how the slope is going, because it looks like it's going down 1 over 2, that would be like right in the middle of that. So it looks like we're at 1.5 for my y values. G of 1, so here's x equals 1. Now notice how it's open up here. So I'm not going to go to this point. I'm going to go down to where it's closed, so down here. So this one's important. With your piecewise function, you're going to the closed dot, not the open. So if this is 0, 1, 2, 3, 4, it looks like this would be negative 4. And then lastly, negative 5 here. So again, if this is the origin, 1, 2, 3, 4, 5. Looks like we came out at 2, 3, 4. Y equals 4. Now, find x when g of x equals 2. So here's another one of those tricky questions, the way we worded it. I'm going to graph y equals 2, which would be that line right there, and I'll label him. And I want to find the x values for when y equals 2. And I see two places. I see here and here. So it looks like at x equals negative 2 would be an answer. And at x equals 3, it looks like 1, 2, 3. And then you're done. All right, now the next and last piece of this, no pun intended, because we're doing piecewise functions, is to graph a piecewise function. So you'll see there are 1, 2, 3 functions making up this piecewise function. I am going to draw up 3 tables to help me organize my data. Okay, so using my calculator, this can help me as well. I am going to, I actually don't need to type this in, but I'm going to anyway. I'm going to type in my first equation, which is 4 minus x. I say not needs to because this isn't too crazy. Okay, now I want the table from here when x is less than negative 2. So this is actually where people mess up. You're going up in the table then. So from negative 2, less than would be negative 3, negative 4, negative 5, and so on. So picking those values, it looks like we would have 6, 7, 8, 9. Now, since this is just less than and not less than or equal, that means this is going to be just an open dot at negative 2. All right, so let's graph this. So I got at negative 2, that's 6, 1, 2, 3, 4, 5, 6. And then plot some more points. 7, 8, 9. And then using a straight edge and a little arrow, and you're doing an arrow because it's when x is less than negative 2, so it's going on forever to the left. Now next is when x equals negative 2. So that would imply a closed dot. We're going to have a y value of 3. So that's just a point. So at negative 2, I'm going to be at 1, 2, 3. Closed, which is good because then we're still a function because this is open and this is closed. All right, and then last guy, go to your calculator again. This can help you. Type in 2x plus 1, and we want the values of x that are greater than negative 2. okay? So greater than -2 would be -1, 0, 1, 2. And again, that's usually where people struggle because they'll look the wrong way in the table. All right, so that means it's -3, -1, 1. And 3, and then 5. Which makes sense because the slope is 2, and those are going up by 2s each time. Now again, because its x is greater than, not greater than, equal to, this is going to be an open dot at -2. So go to -2, find where -3 is, and then finish plotting some points. So we got -1, -1, 0, 1, 1, 3, and 2, 5. That's good. And then with a straight edge, I'm freehanding it because I'm on my laptop. That's the rest of your piecewise graph. And then you're done. And that concludes our Unit 6 video on functions. Hope it was fun.